Alrighty. So video number 2, this is going to be the back page of your assignment for Wednesday. We're using the two-way table, this two-way table for numbers 10 through 12. And it says, a survey was given to all Parkview seniors and the results are as follows in the table. So I see males and females, and then did get driver's license at 16, did not get driver's license at 16. And of course, we left the totals off. So let's go ahead and do that first. Let's go ahead and total these up. So the total students or seniors who did get their driver's license at 16 is 275 plus 209, which is 484. Okay, did not get their driver's license, 97 and 115, 212. So total seniors who took the survey was 696. Right, 484. Let's double check that. 212. Yep. Okay. So now total males, we're going to add the male column, 275 and 97. Give you 372. And then the total females, 209 and 115, 324. And again, when you add up all the male and females, you should also get 696. Perfect. All right. So number 10 says, what is the probability that a senior got their license at 16 given that they were female? Okay, so that word given, keyword. That tells us the part of the table that we're narrowing in on. We're focusing only on the females. So this portion of the table. So our denominator, our sample, is only the 324 females who took the survey. They're telling you the person chosen was a female. Now, of those 324 females, they want to know the probability that they got their license at 16. So did get driver's license at 16. There's the row. How many females got their driver's license at 16? The overlap, 209. That's your numerator. So 209 out of 324. So we plug that in our calculator, 209, 324. We want to reduce it if we can, and we cannot. So our decimal is, well, we got to plug in the right numbers. 209, 324. There we go. All right. So 0.645. And as a percent, 64.5. Okay. Number 11. All right. Number 11. What's the probability that a senior will have gotten their license at 16? Okay. So the probability that any senior who took the survey, that a senior, okay, remember only seniors took this survey. So out of all of the seniors, any senior who took the survey, so our sample is all of them, 696. So out of everyone who took that survey, okay, they want to know the probability they would have gotten their license at 16. So how many said, yes, we got our license at 16? So the total, 484. 484 of the kids who took the survey said, yes, we got our driver's license when we turned 16. So we want to plug that in. We want to reduce it. And we get 121 over 174. Okay, as a decimal, that would be 0.695. Which is 69.5%. Okay. All right. Erase those marks. All right. So 12. What's the probability that a randomly selected senior is a male who did not get their driver's license at 16? Okay. So what is the probability that a randomly selected senior, so any randomly selected senior who took the survey. So we're looking at the total. Our sample is every single kid or senior who took the survey. So out of those 696 kids, how many, okay, were males who did not get their driver's license at 16? So it has to fit both categories. It has to be a male who said that they did not get their driver's license at 16. So I'm going to go to my table and I'm going to highlight the males. And then I'm going to highlight the kids who said they did not get their driver's license at 16. And we want the overlap. 97 males said, no, I did not get my driver's license at 16. So our numerator is 97. So can we reduce that? I think not. And I think correctly. And as a per or decimal, that's going to be 139, 13.9%. Okay, we are so close. We are almost done. Hang in there. We have a couple left. If I can get to it. There we go. Well, not a couple, 3 left. Couple would be 2. All right, final problem. Again, they did not total our rows and columns. We're going to go ahead and do that first. Okay, so has a job, 20 and 587, 607. I don't know why it was erasing this. Okay, 607. Okay, and then doesn't have a job, 245 and 92 is 337. So to get that grand total, we add those together and we get 944. Okay, and then less than 18. So now we're going to our columns. That's going to give me 265. And then 18 or greater, 587 and 92, 679. Okay, and then when you add those together, again, you should get 944. I'm just going to double check to make sure, and we're good to go. Okay, 13. What's the probability that a randomly selected person surveyed has a job given that the person is less than 18 years old? So keyword, given. Okay, that means we are not looking at the entire table. We're not looking at all 944 students who took the survey. Okay, or not necessarily students, whoever took the survey. Okay, we are only looking at the people who are less than 18 years old. They're telling you that was the person chosen. So we're focusing on this part of the table. So our sample are the 265 people who were less than 18 years old. And out of those 265 people who were less than 18, they want to know the probability that the person has a job. Okay, has a job. So we go to has a job, we highlight, and we look for the overlap, 20. Okay, 20 people who were less than 18 years old have a job. So our numerator is 20. Oops. So 20 over 265, you want to reduce that. 4 over 53. Okay, then you want to find the decimal and the percent. 0.075, 7.5%. Perfect. All right, number 14. Says, what's the probability a randomly selected person surveyed has a job given the person is 18 or greater years old? So given, keyword, they're telling you that the person that they chose was 18 years or greater. So now we're looking at this column. Okay, our sample are the 679 people who took the survey that were 18 years old or older. Okay, so of those 679 people, we need to know the ones who have a job. Okay, so again, has a job. There's that row. 18 years or greater. There's that column. We want the overlap. 587 people who were 18 years old or greater said, yes, I have a job. So 587 is our numerator. Okay, 587, 679. I don't think that can be reduced. It cannot. Here is our decimal, 865. So 86.5% of the people who were 18 or older said yes, that they have a job. So that's good. All right, last one, y'all. 15. Let's erase these marks. Okay, what is the probability that a randomly selected person has a job? So what is the probability that any randomly selected person who took that survey has a job? So our sample is everyone who took the survey. So all 944 of them. So out of those 944, how many of those people said, yes, I have a job? So here are all of the people who said, yes, they have a job. The total is 607. So 607 out of 944. Can we reduce it? Negative ghostwriter. Our decimal is 0.643, which is 64.3%. Yay! Good job. Great job, team.